Find a function that models the simple harmonic motion where the amplitude equals 1.4 inches, the frequency equals 0.8 hertz, and the displacement is 0 at t equals 0, and then increases. Simple harmonic motion is given by the equations d equals a times cosine of omega t, or d equals a times sine of omega t. Now these two equations are in the same form as y equals a times sine of bx, or y equals a times cosine bx, where referring to the form above, both c and d are equal to 0. Recall when c is 0, there is no horizontal shift or phase shift. When d equals 0, there's no vertical shift, and the midline is the horizontal axis. So while we are using different variables here, we've already determined sine and cosine functions in this form. Let's begin by graphing the given function. Because the midline is the horizontal axis and the amplitude is 1.4, let's mark positive 1.4 and negative 1.4 on the vertical axis. Now we want to mark one period on the horizontal axis, but here we're not given the period, we're given the frequency. Recall the frequency and period are reciprocals of one another. We can say the period equals 1 divided by the frequency, which means the period is equal to 1 divided by 0.8 or 8/10, which simplifies to 4/5, which indicates the period is 5/4. Recall 1 divided by 4/5 is equivalent to 1 times the reciprocal of 4/5 or 5/4. Now let's mark off 5/4 on the horizontal axis, let's say here. And because we're going to be graphing either sine or cosine, we want to break the period into 4 equal subintervals. And now to begin the graph, we're told displacement is 0 at t equals 0, which means the graph passes through the origin and contains the point 0, 0 here. And because we're told then the function increases, we'll follow the basic pattern for the sine function when the period is broken into 4 equal subintervals, which is starting at the midline, we have a max, then down to the midline, down to a minimum, and back up to the midline. Let's go ahead and graph the given simple harmonic motion. And now let's determine the equation. And we can see from the behavior we'll be using the sine function. The equation will be in the form of d equals a times sine of omega t. To begin, the absolute value of a equals the amplitude. We know the amplitude is 1.4, and because there's no reflection across the midline, we know a equals 1.4. 2 pi divided by omega equals the period, which we now know is equal to 5/4, which means 2 pi divided by omega is equal to 5/4. Let's go ahead and cross multiply. 5 times omega must equal 2 pi times 4, which gives us 5 omega is equal to 8 pi. Dividing both sides by 5, we have omega equals 8/5 pi, or 8 pi divided by 5. But because a is a decimal, let's write 8 pi divided by 5 as 1.6 pi. We would not want to convert to a decimal unless the decimal terminated. The function that models the simple harmonic motion is d equals 1.4 times sine of 1.6 pi t. Remember, we do want a function of t here, not a function of x. I hope you found this helpful.